Hello guys. In the last video we did, um we had a nice example. It was the best example. And of course there are two methods that I did show, or that I did use to solve, finance problems that uses a timeline, right? So personally, I want to say this: I prefer method two, right? And right now, as I continue to solve these problems much further, I will be using method two, right? Cool. Right. So um after a 20-year period, this guy lump sum investment, it matures to an amount 313,550, 313,550 rands. How much did he invest? If powerful, if, right, his oh wait, how much did he invest if his money and an interest of that per annum compounded half yearly for the first 10 years? Cool. And then 8.4% per annum compounded quarterly for the next 5 years. And then we have 7.2 per annum compounded monthly for the remaining period. So this one, it's okay, it's not really complicated much, because the only thing that differs here is what, the only thing that is different here is the change, the interest rates. We have them compounded differently, and we have different interest rate. But as for the amount that this guy had at the end of the 20-year period, it's given to us 313,550 rands, right? That money is the money he's gonna have at the end of the, you see. And now that which is required from us is to calculate how much money did he actually invest. So from this question, you already see they are asking us to calculate the principal amount, right? But the first thing first, before you could even start thinking about the numbers, you need to draw your timeline. Um, so you draw your timeline. So mine, I'll just divide it by an interval of 5. Cool. So this is right here, you have T0. Right here we have T1, let me say T5, T5, T10, T15, and T16. Oh no, T20. Come on, what's going on? T20. Cool. So we have our timeline with a split of 5 years each. And now coming to the interest rate, we are told that we have from year one, actually let me use a different color, from year one, right, up until year 10, we had a different interest rate. And then from year 10, let me use a different color, year 10 till year 15, that's the next 5 years. And then for the remaining period, which is another 10 years, another 5 years, yes. So in terms of the interest rate, so we have 13, wait, we have 13.565 per annum. This one is compounded half yearly, half yearly. Then we have this one, which is 8.4, I believe. Yes, it is. So we have 8.4% per annum. It's quarterly, I think. Yes, quarterly. Then we have this one, which is compounded. Okay, 7.2, 7.2% compounded monthly. Right. Cool stuff. So what usually, okay, so you have your formula. A equals to, let me make more space, your principal amount 1 plus cool. So this is what usually you would have in the formula that we have, right? But I want you to realize something for this problem. So on this problem, we have interest rates, different interest rates for different times, right? There's this one, there's this one, there's this one. If our investment was only up until year 10, this was going to be the end of our formula, right? But now we also have, of course, this period. So this amount of money, after it has gained all its interest here, right, in this blue period, it's going to now gain this much interest. So when it gains that much interest, it's gonna be one. So we're gonna have 3 of these things for different time periods. Hey, Vanessa. Yeah, so right, so now we have our amount that was this is the amount that we had at the end of the 20-year period. And we are calculating the value of P. We don't know what P is actually. It's the one we are calculating. So now I'm gonna make the substitution here for our interest. We have 0.1365 divided by 2 2 multiplied by 10. Yeah, 2 times 10. 2 times 10, right? So where is this coming from? It's this interest rate, ne? From T0 to T10, 10 years, ne? Compounded half yearly, so 2 and then the interest rate, of course. And yeah, so it's like if you knew the amount that you did put in, like your initial investment, it will be P multiplied by all this, ne? And the value, the answer you get there will be your amount at the end of year 10, right? And then that amount at the end of year 10, it's still in there. Now it's going to gain this interest. It's compounded quarterly, so it's 4 times 5, because from T5 to, okay, I mean, they did say that it was for the next 5 years. All right, and the remaining period 0. I think this one is compounded monthly. Yes, it is. So we have 12 times 5 here. All right. Yeah. So after here, it's just gonna be a simple, mathematics. Yeah, it's basically going to be simple mathematics. I'll just write this down. And then I have P. I'm gonna multiply all these brackets. So that means I have oh my god. Yes. I have the right value divided by 2 to the power of 2 times 10. I could have written just 20. Multiply by 1 plus 0.084 that one is divided by 4, and then I still have 20 as well. 1 plus 0, 7, 2, 1 plus 0, 7, 2, wait, divided by 12. And then this one, I don't know the answer. Probably it's 60, but yeah, I don't trust myself with that. But yeah, I think 12 times, yes, it is 60. It is 60, but I will just write 12 times 5. Ah, yeah. 12 times 5, 12. Okay, cool. I'm just checking if everything is fine. I believe it is. So then we take this value, 8.125553. Right, let me just close it there. Then of course now we divide by that value both sides. So I have 313,550 divided by 8.12553, and I am getting the value of 38,588 and 25 cents. Cool. So yeah, this one it was more of like yeah, it was not really that much complicated. Also with the timeline, it doesn't have a lot of complications. I think the one we'll find interesting is this one, because here, let us listen. They say 75,000 rand is invested in an account which offers interest which offers interest at 11% per annum, compounded monthly for the first 24 months. So for the 2 years, the first 2 years, that's the interest there. Interest rate is like 11% per annum. Then the interest rate changes to 7.7% per annum, compounded now half yearly. And then they say if 9,000 rand was withdrawn from this account after 1 year, and then a deposit of 3,000 rand is made 3 years after the initial investment, how much will an account, how much will be in the account at the end of 6 years? Very cool. So here what's interesting is that there is an initial deposit of 75k. After that we have interest changing, we have withdrawals happening, and further another deposits happening. So this one is going to be quite interesting. Let me draw a line in case I may need some space. Yeah. So of course, remember the first thing, the number one thing before you could do whatever, your timeline, right? And now because you know that they're asking how much money we will have at the end of year 6, you know your timeline will be from T1 to T6, right? So 1, 2, 3, 4, 5, and then 6. So that is T0, T1, T2, T4, T6. Now let us talk about what is happening here. For the first 24 months, interest rate is what? Interest rate is 11%, right? So we have that, and then from that period, let me use screen, from this period up until the rest, interest rate changes. So I would say here the interest is it changes to 7.7 per annum, compounded half yearly. And then here we have 11% compounded how? Monthly. Right. So that's not the only thing that's happening. Let's see. Oh, okay. If 9,000 rand is withdrawn in the account after 1 year, right? So this is year one. So here there is minus 9,000 rand. Oh, here there is a plus 75k. Okay, and then wait. A deposit is made 3 years after the initial. So here there's a deposit of 3,000. So plus 3,000. And then that's it. Right, now we have to do our calculations. Okay. So cool. So now that we are done with our timeline, what happens is, or what follows, oh my god. Sorry for that. What follows is what follows is going to be our calculations now. So how I personally prefer to do this thing is like step by step. You see, like method 2, the one we did on the previous video, that's like, it makes sense to me that way. Yeah, so let's go. Let's go. We have, we'll say perhaps A1. Yes, A1 equals to P right. So now here's what I'm gonna do. We invested this much money, and then at the end of year one there's a withdrawal happening. So now I'm gonna calculate the amount of money. If I invest this 75k, I'll calculate how much I will have before I make this withdrawal, né? So okay, you have 75, 1 2 3. That will be I, which is 0.11 divided by 12, and then I'm just gonna have 12. And yeah, so let's see what the value is. 75,000 1 plus 0.11 12 close bracket 12. Yeah, it's, or you could say it's 12 times 1, which is basically 12, you know. So I am getting a value of 83,678.9, yes, 91, right? That's the value I have. And then now we have another A. Let me say this is A2. A2 is after the withdrawal, né? Now I am withdrawing this money, which is 83,678.91 minus 9,000. Man, I could say okay, 83,678.91 minus 9,123. Let me see, 83, so that 7 4 6 7 8 9 1. Now it's like we went back even, because initially we invested 75k, but now we are at after the withdrawal we are at 74k. But yeah, so now we are here. We have already made our withdrawal of 9k, and this is how much we have at the end of that withdrawal. So now this money is still in the bank, or it's still, let me say it's still in the bank. So what's gonna happen with this money, this one, is that it's gonna gain this interest from year 1 to year 2, right? So it has to get that interest. So we go with our calculations again. I believe that is 74,678. And oh, look at this, 6789. We have 1 plus, then the interest is still 0.11 divided by 12. It's gonna be 12, or 12 times 1. So yeah, then to the power of 12, right? So now when I raise this money, like this money, when we now invest it again, we put it there in our account for this duration, ne? Oh my god, I didn't even have to go to the calculator. I didn't even have to. I mean, I could. What I'm doing is correct, ne? What I'm doing is correct, but I was gonna make it longer. Like, so I'm gonna pause. And try to make it shorter as well. So look, we have made our withdrawal, right? Yes. And then there is no other withdrawal or deposit from year T1 to T3. Only up until T3 there's a deposit. So then this interest of 11% compounded monthly, it's from year 1 to year 2, right? And then from year 2 to year 3 there's 7.7 compounded half yearly. So with that, I want to, oh my goodness. Yeah, damn. Okay, with that, I want to expand this thing. I want to expand it. So I'm going to expand it also with the other interest also happening for 1 year. Right. So here, when I'm substituting, I'm gonna have 1 plus 0.07777 divided by 2, then times 2, because look at this, ne? Look at this, it's for this period for 11%, and then this period, this 1 year period, right, for 7.7 before we make our deposit, right? So yeah, I was with what I was doing, I was gonna make it long. So we already have the 12, so we're gonna put another bracket and say 1 plus 0.077 to, believe that is 2. Yeah. So now the value we have is 89. I'll put it in rands. 89,853.86, ne? Okay, and now I'm going to find what? I'm going to find a 4, which is, now remember what happens at the end of at T3. What happens? There's an what is this? We have another deposit. Yes. So now I'm gonna add this amount: 89,859.86 plus 3 thousand. It's gonna be 92, I believe, plus yebo 92,859.86. Right, so now I have already added the deposit that came in. How much time do we have? We have 3 years left, né? It's gonna be 1 2 3, right? So now we are calculating, I could say AF, which is for the final accumulated amount. So we're still using the same formula. So with that we have 92 5986 into 1 plus interest, which is 0.077, divided by half yearly, so divided by 2. Then we have 2 times 6. No, 2 times 3. You know that thing when you are writing numbers and you like the number that you are writing, actually you were multiplying, but now instead of writing the number you are multiplying with, you end up writing the final answer. So we have 92,859.86. yeah, 92,859.86. Then we have 1 plus 0.077 divided by 2, close bracket, to the power of 2 times 3, which is 6. Then the final answer is 116,484,020 right? That there is our final answer. For this question. Yeah, so I want to say this again. I did say I prefer this method. Because it makes sense. You can see like actually what is happening, like from this time to this time, this is what happened, and you make your calculations based on that time period. Then you go on to the next, just like that. It makes sense for me now. But there's this method that I'm going to share with you. I don't think I deeply understand the idea behind the method, but it actually works. So I will do it again. It's the same as method 1, so I will do it again just to show you guys that it works. So what we're going to do is we're gonna write this answer right here, né? We have 116,484, right, 0.20. So we're gonna make our calculations with this method I want to show you, and then we're just gonna compare answers. So there will be 3 parts for this one, because the first part is the initial investment, the second part is the withdrawal, the third part is the deposit, and then after that we get our final value. So let's get started. You have use a different color, maybe red is fine. You have A. So let me just put on the numbers. 75,000 rand. So this 75,000, you are investing it for 0.11 over 12. Then 12 times 2, right? Forget. So we're like, okay, this 75,000 rand is in the bank for 2 years, compounded, our interest compounded monthly, so it's 2 times 12 this period. And then there's another period also 0.077. Let me move this. So this one compounded half yearly, so it's 2 times 4, right? Because now yeah, so it's this money. Imagine that the money never went out, we never took anything out or added anything to the account. This is exactly how it will be. You put that in a calculator, let's see what we get. 0.1112. Then you have to the power of 12 times 2, and then we go again. 1 plus 0.77 2 times 4. Yes, the value we're getting is 126,305.66. Ne? And then now this 9,000 rand, ne? It's a what? It's a deposit. It's a withdrawal. So we have 9k, negative 9. I'll say A1, A2, negative 1. So we have 1 plus 0.11 divided by 12 times 12. So this 9,000 rand, yeah. So we see from T1 where the withdrawal happens up until T2, that's a 1 year period. So it's like this. And from year 2 to year 6, that is 0.7, 0.077. 2 times, then there is 4, right? So we go put that in a calculator. 1, 2, 3. Okay, close bracket. We have 12. So it's just gonna be 12 because it's a 1 year period. I mean, yeah, I've already explained that. I'm just putting things in the calculator now. Two times 4. So we are having minus 13,584.66. Oh, 68. Then the last one, 83, it's going to be the 3,000. 0.772. It's gonna be 2 times 6. 2 times 3, I mean, which gives us 6. Cool. Let's see. Cool. No mistakes. 1, 2, 3. No mistakes. So now the final answer, A total, is going to be the addition of A1 plus A2 plus A3. All right, so A1 we have 101.26, I think, 126,305.66. Then we have a plus. Actually, it's even a minus 13,584.68. Then you have a plus 3,763.23, right? And then you put this in a calculator. Let's see what we have. 126 305, no, minus 13,584.68, right, plus 3,763.23. Look at what we are getting. So now our value will end up with 116,484.21. And remember, this is the value we got, right, using method 2, and now this is the value we get using this other method, right? I can't explain like why the second one works. Or perhaps I can try, but I doubt my explanation, because my thoughts is like, I don't know why it works, but it works. So yeah, I think if I try to explain this, I'll be unnecessarily making the video longer than it has to be. Sure. Yeah. I think let me call it a day on this video. Yeah, let me call it a day on this video. We will do more example on the next. See ya.